now, we've seen a good amount of the fundamental things Python is capable of. We've seen how we can use and define our own functions. We've explored the base data types we'll be using, and some of the more high-level ones, like dictionaries and arrays. One of the last fundamental features of Python we've yet to tackle is that of classes and object-oriented programming. Using classes and objects, we can define ways to structure data and run functions, or use ones that have been defined by other developers. This is an invaluable tool for designing and organizing our programs in such a way that is both efficient for the computer at the low level and intuitive and easy to visualize and understand for us at the high level. While it can be initially difficult to wrap one's head around when it comes to first learning to code, it becomes much simpler very quickly once you grasp the fundamentals. Today, we'll be going from having no knowledge of object-oriented programming to, hopefully, it feeling like second nature. A simple way to think of classes is to first think back to functions. We know that using functions, we can define our own processes along with the data we want to go into them and the data we want to come out, what we want them to return. We can then use these functions again and again, almost like little mini programs inside of our program in different contexts. Classes are similar. They're things we can define ourselves or use inbuilt or imported ones to be reused in our program in different contexts. Only, while functions tell our program what we want it to do, classes tell our program what kind of objects and items we want it to have. Remember that word objects for later. Think of functions as verbs, a thing that is done, and classes as nouns, things that are. Let's look at an example. Often classes are used as representations of real, tangible things. Let's say we want a way to represent students at a university in our program. First, we would ask ourselves, what about each student do we want to represent? For the purposes of this example, let's say we want to know their name and which year of study they're in. Already, we have a pretty good template for what a student would look like. Note that we haven't said what any of these values would actually be, only that they would be there, and crucially, that they could be any number of different possible values. They're like variables for each individual student. We call each one of these template values fields or properties. Next, we might think about what we want our students to do, or what we want to be able to happen with them. Let's say we want a student to be able to introduce themselves with a short message and to continue on to the next year of their studies, thus increasing their year of study by 1. If fields were like variables inside of a class, think of methods as being like functions. This template, which tells us what we want to know about each student and what we want them to do, is our class. It is using this class that we declare each individual student. These individual students are our objects. Once an object has been instanced, created, they become their own thing, separate from any other objects and from the class itself, even though it's still based on the class. If we change any of an object's field, they will be changed for that object only. If we call any methods from that object, they will be called from that object only. This doesn't mean that objects can never interact with each other. In fact, we can even define methods in the class explicitly for interaction between objects if we want. It just means that they are separate. We learned what classes and objects are in theory. In practice, how can we implement them into Python? Python has its own syntax for defining classes. Here, we've started to define our own class using the class keyword. We've given it a name which by convention starts with a capital letter. The block below this line is where we'll be defining our fields and methods. See how this looks very similar to how we define a function, only this time the keyword is different and we've left out the brackets. Before we move on, there's one more thing to explain. Most implementations of OO programming, including Python's, utilize something called a constructor. The constructor is a special method which most classes will have, which is run as the very first thing after a new object is instanced, in order to populate it, that is, to fill out its fields, and do any other setup work that might be needed. In Python, the constructor is written like this. Seeing as how we've already covered the basics of functions in Python, you should be able to make some sense of what's going on here. However, you may be left with a few questions. What does init mean? And why are there double underscores on either side? What is self? And why does it look like we're defining variables as themselves? Let's address those. Firstly, init is short for initializer, which is another term for constructor. And yes, it does need to be called that. If we tried giving it any other name, Python wouldn't recognize it as the constructor. This is because init belongs to a special group of methods with predefined names, sometimes called magic methods or dunder methods, which have their own special syntax reserved for calling them. Of these methods, init is the only one we need to understand today. Next, the self field. As you may be able to guess, self refers to the individual object of the class in question. In the case of init, the constructor method, this is the newly created object which we want to fill in the fields of. Every method of a class, with a few exceptions we won't be covering today, requires the self object to be the first parameter of the method, even if the method doesn't have any parameters otherwise. Fun fact, unlike init and the other magic methods, we don't need to call it self. We can give it any valid name we want and it will still work. However, out of convention, self is the name that's used pretty much everywhere, so it's highly recommended that we stick to it. In Python, this syntax refers to the field name of the object self, which, remember, is our brand new object, the one we're constructing. Name and self.name are actually two completely different variables. And because self is brand new, self.name is empty. What this line does is define it as the value of name, one of the parameters of the constructor. After running this constructor, we'll have a shiny new object with two fields filled in. Now, we have a simple Python class definition, including a working constructor. How do we go about creating objects of our own, i.e. calling the constructor we just defined? This is actually, you'll be relieved to hear, the easiest part. All we do is write the name of the class followed by brackets. And inside of these brackets, we fill in the parameters we defined in the constructor, except for self. We never need to explicitly fill in self, as Python does it automatically anytime we call a method from an object. You'll notice we didn't actually call the constructor by its name init. This is because we don't need to. Again, Python does this automatically every time we call a new object to be created. If you like, you can imagine the constructor as being a function which shares the same name, capital letter included, as the class it's defined for. While this isn't quite accurate as to what Python really does behind the scenes, it's a helpful way of remembering the syntax you'll be using for it. Only thing we need to do now is actually store our new object. We can do this by assigning it to a variable, adding it to a list, in a dictionary, or really anything that we can do with any data in Python. So, we've introduced OO as a concept. We know what classes are and what objects are. We know what objects of classes are, and we've taken our first look about how we can define and use them in Python. In the next few sessions, we'll be looking at how we can use Python to define methods, some more advanced uses of fields, and later introduce the idea of inheritance and what it means in the theory of OO and how it's done in practice in Python. But for now, we should take some time to review what we've just learned and really internalize OO as a new concept before moving on later.